Hi everyone, this is the Radical Tutor here explaining, and in this video we are going to look at this question which is coming from linear algebra. This is linear algebra 1 and it is coming from eigenvalues and eigenvectors. So our question says that prove that if the eigenvalue of A is lambda, then the eigenvalue of A inverse is 1 over lambda. So they want us to prove that if the eigenvalue of A is lambda, then the eigenvalue of A inverse is 1 over lambda. So in other words, what happens is that if you are given to say the eigenvalue of A is 2, then the eigenvalue of its inverse, or the eigenvalue of the inverse matrix, is 1 over 2. So this is the concept that we use, or the theorems that we use when getting the eigenvalues of A inverse. So if you are given the eigenvalue of A to be 2, then the eigenvalue of its inverse becomes 1 over 2. Now the question is, they want us to prove that how do you know that if the eigenvalue of A is 2, then the eigenvalue of its corresponding inverse is the reciprocal of the eigenvalues of the original matrix. That's what we are trying to prove. Now, us doing that, what we are going to do is we are going to start by defining what an eigenvalue is. So what is an eigenvalue? So we define an eigenvalue as, so we say that an eigenvalue, so we say a scalar lambda is said to be an eigenvalue, of A if and only if it satisfies the condition, A times x is equal to lambda x. So a scalar lambda is said to be an eigenvalue if it satisfies this condition. So in case they ask you or they ask you to define an eigenvalue, this is how you're supposed to define an eigenvalue. So that's how you define an eigenvalue. So a scalar lambda is said to be an eigenvalue of A if and only if it satisfies this condition there. Now, what we're going to do is we want to prove that if the eigenvalue of A is lambda, then the eigenvalue of A inverse will be 1 over lambda. That's what we're trying to prove. So now, for you to prove this, what you're going to do is you have your condition here. So this condition that we are given, you are going to introduce an inverse. We are going to introduce an inverse in order for us to prove that A inverse is equal to 1 over lambda, because in the condition that we have here, we don't have an inverse. So what can we do? We are going to introduce an inverse in that condition for an eigenvalue. So we have Ax is equal to lambda x. Now for you to be able to prove that A inverse is equal to 1 over lambda, it's just a matter of you multiplying this equation throughout by A inverse like that. So if you are to multiply A inverse times Ax, we are going to get Ax A inverse. And then this is equal to, or if you want, you can write it as A times A inverse. So I've multiplied this times that, which is giving us the A and the A inverse. And then we also do the same, this times that, which is going to give us, remember, don't forget that when we've multiplied this and this, we've gotten A inverse and the x. So don't forget to write the x there, which is going to be x here. And then is equal to, we also multiply A lambda, A inverse times lambda times x, we get A inverse times lambda times x. So this is what we're going to get. To multiply this and this, you are simply going to get the lambda x times A inverse like that. Now, from here then, we need to use the properties of determinants in order for us to prove that A inverse is equal to 1 over lambda. So which properties of determinants are we going to use? We are going to say that whenever you multiply A times its inverse, whenever you multiply matrix A and its inverse, the answer that you get is always an identity matrix, then times that x there. This is equal to, you come here, you also say that you have the lambda times x times A inverse. So that one you can write it the way it is, which is lambda times x times A inverse. Now, what we want to do here is to make sure that we make A inverse a subject of the formula. But before we make A inverse the subject of the formula, look at this. We have identity matrix times a matrix there. So whenever you multiply identity matrix with any matrix, the answer is the answer is that matrix itself. So whenever you multiply identity matrix times that matrix or any matrix, the answer is identity matrix. The answer is that matrix itself. So that's what we're going to do. So now from here, we say the answer that we're getting this side is x is equal to, we come here, we multiply lambda times x times A inverse. We are going to have lambda times x times A inverse. Now, what we need here is to make A inverse the subject of the formula. Remember what we are proving? We are proving that A inverse should give us 1 over lambda. So that's what we are proving. So here, if we are to make A inverse subject, we are going to say over lambda x over lambda x. And then this and that will go. And that means our A inverse is then going to be x over lambda x, meaning that the x and x will go. We are going to remain with 1 over lambda. So A inverse is equal to 1 over lambda, and therefore this becomes our final answer. Alright, so that means that we've proved that if the eigenvalues of A is lambda, then the eigenvalue of A inverse is 1 over lambda, which we've actually proved here using the condition or the definition of eigenvalues here. Alright, so this is how you can prove that question, and that means that you are done with proving that if the eigenvalue of A is lambda, then the eigenvalue of A inverse is 1 over lambda. Thank you so much for watching this video. Don't forget to follow my YouTube as well. Subscribe there for more videos. Follow my page as well, Facebook page, and also follow me on TikTok.